In today's lesson, we're going to be talking about the dot product. What the dot product is a way to multiply two vectors together. In this situation here, we have vector AC, which we want to multiply by vector AB. These vectors have an angle of theta between them. To calculate the dot product of vector AC and AB, which is denoted with this symbol here, AC dot AB, by definition of dot product, is the magnitude of AC times the magnitude of AB times the cos of the angle between them. Let's take a look at some properties and consequences of the dot product. With the dot product here, we do have some common properties. Because the multiplication is the main element of the dot product, commutativity is possible, right? Because multiplication is commutative. If I want to calculate this will be the magnitude of P times the magnitude of Q to the cos of the angle between them. But by definition, this is the magnitude of Q, magnitude of P, cos of the angle between them. Multiplication is a commutative operation, so magnitude of P times magnitude of Q is going to equal magnitude of Q times the magnitude of P. Likewise, here you have distribution with the dot product for similar reasons because of multiplication. So that means given the dot product of vector P with the sum of two vectors, you can distribute that vector into the brackets here, and then the dot product goes between them. This one here, if you take a look, if by definition, vector P dot vector P would be magnitude of P times magnitude of P to the cos of the angle between them. But the cos of the angle between two of the same vector would be 0 degrees. And as you know, the cos of 0 degrees is 1. So this becomes the magnitude of P squared. And lastly, we have associativity is also applied with scalar multiplication. If you multiply a vector by some scalar k, that scalar k can either be put completely out and just take the dot product of the vectors first and then take care of the scalar, or you can pass that scalar to either the second vector or the first vector and take the dot product. You will get the same answer. And again, the reason for that is because multiplication is a commutative operation. Let's take a look at working with some examples. For our first example here, we have to consider two vectors, magnitude of 5 and magnitude of 3, and there's an angle of 60 degrees between them, and they want us to go ahead and calculate some of these operations here. Let's take a look. So if I want to calculate A dot B, that's going to be the magnitude of A, magnitude of B times the cos of the angle between them, which is 60 degrees in this case. So magnitude of A, let's go ahead and define vector A as having magnitude of 5, and we'll let vector B be the vector that they're discussing having magnitude of 3. This will obviously be 5 times 3 times the cos of the angle between them, in which case calculating this we get 15 over 2, which is 7.5. Continuing here, we have dot product with scalars involved now. So as we discussed, if you want, you can push the scalars completely out of the expression. So in this case here, I can rewrite this as 2 times 3 with A dot B, in which case this will be 6 times A dot B, but we had just calculated A dot B, and we know it's going to be 7.5. So in which case here we end up getting 45. For this next example here, we have A dot A. Calculating that here, we know that A dot A is just the magnitude of A squared. Well, the magnitude of A is 5. This will be 5 squared, in which case we get 25. And lastly, we want to apply our distribution here. So to tackle this one here, we can first distribute vector A into the brackets, in which case this will be A dot negative A plus A dot B, and then we're going to just go ahead and distribute the 2B into the brackets, in which case that'll be plus 2B dot negative A plus 2B dot B. Continuing on here, again, you can pop that scalar out in front. This will be negative A dot A plus A dot B minus 2B dot A plus 2, and we've got B dot B. So as we discussed here, this will just be negative magnitude of A squared A dot B we've already calculated, and we got 7.5. B dot A, because of commutativity properties, vector A dot B and vector B dot A are the same, so therefore vector B dot A will also be 7.5 plus 2, and this will be the magnitude of B squared this time. Well, this will be 5 squared plus your 7.5 minus 2 times 7.5 plus 2 times 3 squared. Calculating all of this, we get negative 14.5. For this example here, they give us two vectors, a plus 3b and 4a minus b, and they tell us that the vectors are perpendicular to one another, and they give us this property relating their magnitudes. They want us to find the angle between the two vectors. Well, by definition, if the vectors are perpendicular to one another, what do we know? If the vectors are perpendicular to one another, then I know that by definition this will be a plus 3b dot 4a minus b, by definition, is going to be the magnitude of a plus 3b times the magnitude of 4a minus b times the cos of the angle between them is going to be 90 degrees now. And because the cos of the angle between them is 90 degrees, because they are perpendicular, we know the cos of 90 is 0, which now means that this whole expression is 0. Therefore, we know that a plus 3b dot 4a minus b is 0. So this is a key result here that we'll use quite a lot. Whenever you know two vectors are perpendicular to one another, you know their dot product between them is 0. Now we're going to go ahead and do our distribution properties, in which case here you end up getting 4 times the magnitude of a squared minus a dot b plus 12 times b dot a minus 3 times the magnitude of b squared is equal to 0. Now, because of commutativity properties, I know that b dot a and a dot b are like terms. You can think of them as like terms. So in this case here, this becomes 4 magnitude of a squared plus 11 a dot b minus 3 the magnitude of b squared is 0. Since the magnitude, if you recall, they told us in the question the magnitude of a is twice the magnitude of b, I can get rid of the magnitude of a, and I can replace that with twice the magnitude of b, in which case here, now this becomes, so collecting up like terms here, the b squareds together, I get 13b squared. I'm now isolated for a dot b, and we now have this expression here. Let's use our definition of a dot b. Well, I know that a dot b is magnitude of a, magnitude of b, the cos of the angle between them. This is what I want to isolate for, because that's going to give me the angle between a and b, which is our goal. Well, I know the magnitude of a is twice the magnitude of b, so this will simplify to become 2 magnitude of b squared to the cos of the angle theta. So therefore I can sub this in, and then I can go ahead and isolate for the cos of theta, in which case I get, notice the original question had said b is non-zero, therefore these cancel. So you end up having the cos of theta is negative 13 over 22, in which case I can take the cos inverse, and I get the angle between the two vectors is 126.22. That concludes today's lesson on dot product. Thank you.